Okay, so we're back to talk about the discoveries that you are hopefully making with the end behavior of polynomial functions. So the first thing I want to look at is why do some of these face, both arms face the same direction, either both up or both down, so like the top half of this page, whereas other polynomial functions have one arm up, one arm down, like we see on the bottom half of this page. So what I want to do is have you focus on the exponents, the highest power that you see on these polynomials on the top half here. And so if I'm looking at these, I see an x to the fourth, an x to the sixth, an x to the fourth, an x to the sixth, 6, 4, 8, 4. What do you notice about those exponents? Now let me contrast those with what we see down below. So I'm looking at the highest power, x cubed, x cubed, x to the fifth, x to the fifth, x cubed, x cubed, x to the fifth, x to the fifth. What do you notice about those numbers? I see 3s and 5s down there. Also, linear things have that function, exponents of 1, because they go one arm up, one arm down, if you think about it. Quadratics are more like these at the top of the page, where you have x squareds and both arms go up or both arms go down. So the exponents we see in the top half are 2s, 4s, 6s, and 8s. The ones that generate pictures like the bottom half would be like exponents of 1, 3, 5, 7. So it's even or odd exponents as the highest power I'm talking about. I'm ignoring all of the other terms, just focusing on that highest power. That's what will make both ends go the same direction if the exponent is even, the biggest exponent. If the biggest exponent is odd, we're going to have a split where one goes up, one goes down. Now let's look a little bit more about what happens. Why do the ones on the left of this page go up and the ones on the right go down? And I want you to think about what you know about parabolas. What was it in a quadratic function that made the parabola face up versus facing down? It was the a value, right? So let's look at the ones where both ends go up here. So we have an x to the fourth as the leading term there. What would be that coefficient? That's a 1. The x to the sixth, that would have an exponent or a leading coefficient of 1. A 5, a 3. Those all face going up. Now let's look on the right side of this page. My leading coefficients are -2, -0.1, -1, -3. So, and those all have the ends going down. So just like A made parabolas face up or face down if it was positive or negative, same thing is happening with these even exponents. If the leading coefficient is positive or negative, it will determine what the end behavior does. Now let's look at these ones that the arms are split. This comes from odd exponents here, where the highest power is odd. Think about lines. What makes a line slope up or slope down? Well, that would be the slope. If it's positive, it goes up. If it's negative, it goes down. So just like we read slope from left to right, we're going to look at these from left to right. And if you look on the left-hand side of this page, all of those basically go uphill as you read them from left to right. I know there's some funky stuff in the middle of these. We'll deal with that as time goes on in this class. But overall, these go up from left to right. And if you look at the leading coefficients, in front of the x cubes, there would be 1s. The x to the fifth has a leading coefficient of 1, and then 2x to the fifth. Compare that with what you see on the right hand of this page. Those have leading coefficients of -4, -1, -1, -0.2. So if it's negative, it's going to have a basic downhill slope as you look at it from left to right. So just like lines in that regard. So I think that is everything. There's nothing to submit for today. So remember that Jesus loves you and so do I. So do your math.